Okay, see Lindelof videos, calculus, differentiation with the quotient rule, product rule, and chain rules. So here's a problem that was submitted to me, and this problem is actually a power rule problem, but this student decided they wanted to do it as a quotient rule. So that's totally cool because you can do this as quotient rule. So this person chose quotient rule. Like, all right, if you're going to do quotient rule is, to me, is the biggest pain in the ass of all the rules because it's so much stuff, but it's fine. So first I'm going to gather up all the crap I need. The top function I'm going to call f of x, and I'm going to say that that's 6x squared. I'm going to take its derivative, and that will be 12x. And then I'm going to take the bottom function, which is equal to x to the 1/2 power, so I can differentiate, right? And then g prime at x will be equal to 1/2 x to the negative 1/2, right? 1/2 times this front thing, decrement this, right? Reduce this by 1. So 1/2 minus 2/2 is negative 1/2. So there's this. And then I'm going to start building out my quotient rule. And the quotient rule says that dy dx of a quotient of two functions is equal to g times f prime minus f times g prime all over g squared, right? So that's what I'm going to build. So I'm going to start doing my derivative, just taking my pieces. G of x is equal to x to the 1/2. F prime should have been 12x, right? Is times 12x, isn't it? And then this negative sign is this one. And then it says that we're supposed to take the original function, which is 6x squared, times the derivative of the second, which is 1/2 x to the negative 1/2 power, right? All over x to the 1/2 power squared. And this is going to be our f prime at x, isn't it? So there's our f prime at x right there. I'm going to simplify this out. Like you have to kind of get this for a second because this is x to the first, so it's x to the 2/2. Because remember, when we multiply like bases, we add their exponents. So we'll get 12x to the 3/2 power, right? Minus, and then we're going to get half of 6, right? 6 times 1/2 is 3. So 3x squared times x to the negative 1/2. Oh, right, because this is, right, this is squared, so it's the 4/2, isn't it? So 4/2 plus negative 1/2 is 3/2, isn't it? So also 3x to the 3/2 all over. And the square, in a square root squared, it's just itself, isn't it? So if I square a square root, the radical goes away. F prime at x. I get that, and I simplify all this crap out, and we get this, right? We get 12x to the 3/2 minus 3x to the 3/2 is 9x to the 3/2. So 9x to the 3/2. So 9x to the 3/2 over x to the first, which is x to the 2/2, isn't it? So we would get 3/2 minus 2/2 is 1/2. So square root 9 square roots of x, right? So I hope this was helpful. Look, this could have been done so much more easily. Can I just show this really quick? It said that f of x was equal to 6x squared over x squared, right? X squared, let's look at this again. X squared is the same as x to the 1/2 power. Because of the rules of exponents, how we simplify them, these bases match, so we're going to subtract 2 minus 1/2. So this is the way I do it, just so I can see it myself. You don't have to do it this way. But I would get f of x, right? Not a derivative, but just f of x is equal to 6x to the 3/2 power, isn't it? Can you see that? 4/2 minus 1/2 is 3/2. So if I differentiate, it's a hell of a lot easier, doesn't it? F prime at x. 3/2 times 6 is 18/2. X, now we have to decrement, so we have to subtract 3/2 minus 1, or 2/2, 1/2, right? 18 over 2 is 9. X to the 1/2 is square root x, isn't it? So I get that this person, her argument was that she could do this using quotient rule, and I don't disagree. You can definitely do it, but look at all that crap we went through to get there. So I feel like it was a ton of work. when we could have possibly simplified first. So I guess what we might get from all of this is that make sure that you take a quick look and see if something can be simplified into an easier form. So, hey, thanks for watching. If you have questions or comments, please let me know. And if you haven't already subscribed, please do. I appreciate it.